Hello everyone and welcome to examples 4 for binomial distribution. So for the first question we have a biased dice, so the probability of it landing on a 6 is 0.4. Now we're asked to find the mean and the variance of the number of 6s if we throw it 50 times. So if x is the probability of getting a 6, and it can be represented binomially like this because n is 50 and p is 0.4. Now finding the mean, which can also be expressed as mu or e of x, the expected value of x, is equal to np. So if we times 50 by 0.4, we get our value for the mean, which is 20. The variance var x or sigma squared is just as easy to calculate using np times by 1 minus p. So putting the relevant values in, we get the value 12. To work out the probability that we get exactly 22 sixes, we can use the binomial formula, where x is 22, n is 50, and p is 0.4. So first we can put all the numbers into the equation, and then we can use the combinations formula to work out 50 choose 22. Then if we type all the numbers into the calculator correctly, we should get the answer of 0.0959. Next, the probability of throwing less than 17 sixes is the same as saying the probability of throwing less than or equal to 16 sixes. Now, because tables are cumulative, we can read any number that is less than or equal to directly from the tables. So here's the table for n equals 50, and if we read down the 0.4 column to 16, we get our answer of 0.156. And for more than 25 sixes, x is greater than 25 is the same as x being greater than or equal to 26. And because each column adds up to 1, that can also be written as 1 minus x is less than or equal to 25. And because we can read values of less than or equal to from our tables, we can work out the answer, which is 0.057. In the next question, we have 50 coloured drawing pins. Now, about 3 in 20 are red. That means about 15 out of 100 are going to be red, so we have a probability of 0.15. As in the previous question, the mean is calculated by n times p, and here n is 50 and p is 0.15, so we can calculate the mean as 7.5. Likewise, the variance as np times by 1 minus p comes out as 43.625. Next, we can use the binomial formula to work out the probability of choosing exactly 7 red drawing pins. Put the numbers into the equation like this, use the combinations formula to work out 50 choose 7, and if you put the numbers in the calculator correctly, we should get the answer 0.1575. To choose more than 10 red drawing pins is the same as saying more than or equal to 11 red drawing pins. And also as previously, that's the same as 1 minus the probability of x being less than or equal to 10. Now, as we can read values for less than or equal to from the cumulative tables, we'll find the tables for n equals 50, read down the column of 0.15 to get the value of the probability for less than or equal to 10, and therefore we can work out our probability as 0.12. For choosing no more than 8 red drawing pins, that's x is less than or equal to 8, therefore we can read the value directly from the tables, and it's 0.668. And to choose between 6 and 12 not inclusive means that x has to be greater or equal to 7 and less than or equal to 11. So we can get our answer by reading the value of x is less than or equal to 11 from the tables and subtracting x is less than or equal to 6, giving us 0.576. And for the last question, the probability that Elaine watches the evening news is 0.25. So if we're looking at the next 30 days, n is 30 and p is 0.25. So the mean comes out at 7.5 and the variance comes out at 5.625. To work out the probability for exactly 9 times x is equal to 9, and because x is equal to an exact value, we can use the binomial formula to work this out. N is still 30 as there are 30 days in April, so we can put the numbers into the equation. We can use the combinations formula to work out 30 choose 9, and we should get the answer 0.1298. To work out the probability for either 7 or 10 times, we put x equal to 7 or x equal to 10. So because they're exact values, we again use the binomial formula to work out the probability for x equals 7 and for x equals 10, and then we add them together to get our final answer, which comes out at 0.2571. If we want the probability between 8 and 14 times inclusive, then x is greater or equal to 8 and less than or equal to 14. So if we get the value for x is less than or equal to 14 and subtract x is less than or equal to 7, we should get our answer. So locating the table for n equals 30, we can work out the answer, which is 0.483. And finally, for more than half the evenings of the month means that x is greater than 15, which is the same as saying x is greater than or equal to 16. And as each column adds up to 1, x is greater than or equal to 16 is the same as saying 1 minus x is less than or equal to 15. And we can read x is less than or equal to 15 off the tables. And so our final answer is 0.001. So that's it for this video. Thanks again for watching. And if you could please hit the like if it's helping you and subscribe, that would be great. See you in the next one.